Hi, let's work this one problem, and I'll do all the things that you need to do, and then you can work some of the example problems that are similar but a little bit different. So we'll construct X charts, X bar charts, and R charts, and we'll look for patterns, see if there are any that are outside of the upper or lower control limits, and then we'll check to see if the process is capable. Those are the things that we'll do. So here's some sample data. There's some sample data, and we want to see if that data is in statistical control. By statistical control, we mean that the means of the samples are within the upper and lower control limits, and the ranges of the samples are within the upper and lower control limits. So we're interested in X bar and R, and we'll create the lower control limit for X, and the upper control limit for X, and the lower control limit for R, and the upper control limit for R. So we'll compute all these different things. The X bar is the average or the mean of the sample for that day in this case. And the range is simply the max of the samples minus the min of the samples. So there's the max minus the min, and that's the range. That's the range for that sample. Then we can take these and fill down and double click, kind of verify, yes, that all looks correct. The average looks okay. And then the X bar and the R bar, those are the means of the samples. So we could do average, and we could double check. So yes, those are the averages. Yes, that is the average. I'll move those down a little bit. So this is the X double bar, and this is the R bar. Those are those numbers there. Now we want the upper and lower control limits for these sample means and these ranges. And those are calculated when using this chart here, where you look up the sample size and then you figure out what A2 and D3 and D4 are, and from those you can calculate the upper and lower control limits. And I do all this for you. All you have to do is enter the means, the average range, and the sample size. Well, what is the sample size? Well, I've got 6 samples, so n equals 6. That's the sample size. So it's 86.4 and 12.7. I'm going to copy those. I'm going to paste them here, but when I paste, I want to paste the values only. If I paste the formulas, I'd get a bunch of bizarre numbers. So just the values. The sample size is 6. So here are my upper and lower control limits for X and the range. I'll copy those and move them over here. I'll paste them there. And again, I'll paste just the values. I don't want to paste any of the formulas, because then it would just be a big mess. Okay. And I'll shrink these down a little bit. So those are my upper and lower control limits, and I can create charts using these by saying, here's my lower control limit for X, and here's my, oops, got that backwards. No, that's right, lower control limit for X. Here's my upper control limit for X. Here's my lower control limit for R, it's 0. And my upper control limit for R. And I'm using absolute references on all these, so I can fill them down. This is so I can make a chart that looks nice. This is how you'd make a chart. I'd select these values here, and if I hold down the control key, I can select those columns as well, and then I can insert a chart and it will look like that. And let's see if it'll let me do this. This is one thing you can do. The average is about 86, so there's about the average. So I'm trying to draw a line there at 86, and then I look at the data and determine, do I see any patterns here? And no, I don't see any points outside of the control limits. I don't see any erratic behavior. I don't see a run of 4 or 5 points above or below the mean. So the X bar looks like it's in control, and so it's centered. So the process looks like it's close to being centered around the mean of the means. And then we can look at an R chart too to see if the dispersion is all right. So I'm holding down the control key to select these discontiguous cells, and I'll insert a chart. This is my R chart, and so you look at these together, the X bar and the R, and the mean is about 12. Let's see if it'll let me draw a line here. So there's about 12. If I was to draw a line like that, that's about the mean. So this is one way of doing this. I could graph 12 there, but this looks like it's pretty good. There's a lot of numbers above the mean all along here, all in this area here. These are all close to or above the mean. So maybe that's something to look at, but we're still far away from the upper limit of 25. So the process looks to be in statistical control. Now we could say, is it capable? Is it capable of meeting spec? Well, the specs are upper spec limit of 100 and a lower spec limit of 70. So the difference is equal to 100 minus 70. The standard deviation, or the sigma, is equal to the standard deviation of the population. Oops, sorry, let's say it's of the sample. These are all samples here. So there's my standard deviation. So it's about 4.6, 4.7 for all of those. And the process capability is simply, it's called the CP, it's simply equal to the difference, the upper minus the lower spec limits, divided by 3 times the standard deviation, or the sigma. And you want that to be above 1. Now, is it centered? So we look at the upper spec. How far is this mean, this X double bar, from the real center? Well, the real center is about 85. That's 15 away from 70 and 15 away from 100. So we'll look at the upper spec limit minus the mean, and the mean minus the lower spec limit. We'll pick the smaller of those two and look at the CPK value. So that's mean minus, there's the min, and here's the upper minus the mean, and the min of these two is 13.6, and the CPK is equal to the min divided by 3 times the standard deviation. So it's 1. Oops, this is supposed to be 6. It's usually 6. So we want that to be above 1. If it's at 1, then this means that it's a 99.7% are meeting spec. So that's pretty good. So for both of these, yes, it's pretty close to meeting spec. If it was 2 sigma, then that would be 3.4 defects per million. So this is actually about this is 99.73%. So this is about 2,700 defects per million. So there I've done the X bar and R charts, computed the upper and lower control limits, looked to see if any were outside of the control limits. I looked for patterns, and then I calculated the CP using 6 times the standard deviation and the CPK, and determined that they were meeting spec, that were capable of meeting spec.